Bismillahirrahmanirrahim. Good evening, everyone. Today we'll start to learn how we can use Match program as a beginner. At first, let me start from this simple presentation. This PowerPoint, how we can use the Match program as a beginner to analyze data. At first, let's know what is the Match program before we learn how we can use it. Match is a software to what? Software for face analyzing using powder diffraction data. This software for face analysis. It compares with what? We have two important things in this program. We have comparison between these two important analysis. The first one will be our analysis. The second will be something like knowledge or known data faces according to some faces. And the program will start to do compare between all of these to can take the best matching analysis. Something like that. It compares the diffraction patterns of our samples, to database containing reference patterns of known faces. To find out what? To find out which faces might be present in our samples. Which faces might be present in our samples. Additional knowledge about the simple like noun, faces, elements, or density can make this mission be easier, can be applied, restrict the number of suggested solutions. Actually, when we'll start to use the match program by using our data, we will have a huge numbers of suggestion solution. When we use simple knowledge, when we use simple options, you can minimize these suggested solution numbers, like faces, elements, density, and we can increase these few suggestions, these few options will increase with experience, sure. Now we will try to learn how we can use it as a beginner. Can be applied to restrict the number of suggested solution. In addition to this qualitative analysis, here we have qualitative analysis. After that, a semi-quantitative as well as a quantitative analyzing using retrieval refinement. This retrieval refinement is in Foolproof. Foolproof is another program. At first, we will use it from Match program, and we will learn how we can do that. In addition, it's possible to create a user database based on our diffraction patterns. The user database patterns can be edited manually. Actually, we will work on it manually. We can work on it automatically. It's easier, but the results will not be the best. Okay, but by manually we can analyze our data better. We can minimize the impurities better, and we will see we have a line. It's act to us the comparison between our data and the knowledge or the program data, and must be approximately like line to be our data acceptable. Calculated from crystal structure data or imported from your college's user database. If we intend to run interval refinement calculation, and sure, definitely we will use it by using foolproof wavefront match, so that match can detect the presence of foolproof automatically when it is first run. Now, here our simple presentation is done by using the PowerPoint. Now let's go directly to match. Actually, I installed it from Google. At first 2 months, it's for free. After that, you must pay. Be careful to that. Let me. At first, the program will suggest it to me the director, which database you want it from, which section, from which volume, E, F, D, whatever. Now, let me come back to one first. Now, let me work on, for example, calcium, multiple 5 mol. Is my data. And I will go to raw, RAW. It's the best file, acts to me the best database, or can give me more options. Or, yeah, something like that. Let me select it. Open, Bismillah. Now I'm working on X-ray. The type of radiation is X-ray. But what about wavelength? It's better to select this wavelength, CU/KA1. Okay. Now my diagram. This line acts to me the, how I can say, the first line, the not input. I have input, output, and this the first line. This first line acts to me the impurity diffractions by using X-ray diffractions to analyze my data. We have some impurities here. Not impurities, sorry. It's the impurity diffraction. If I use impurity diffraction, I'm sure it will be better to illustrate this situation. Here, the impurity diffraction to X-ray diffraction to my data acts like that. This line must follow approximately the curves. Let me delete some of these points here by put the pointer mouse on it and push pass right click. No, doesn't work. Let me do that again. Yes, it's disappear, 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 disappear. Now let me increase this line a little bit more. No, 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 no. Yes. Ah, something like that. Let me remove this point here. Remove this one here. Yeah, yes, now it's better. Yes, now approximately it's better. Wow. Let me remove this one. I couldn't, I don't know why. Okay, let me remove this one. Huh. That's it. Yes, now it's better. Now let me work on it. I worked on lanthanum, manganese, calcium with 3 atoms of oxygen to could work on perovskite oxide. The its contents were lanthanum, manganese, calcium, and 3 atoms of oxygen. Because that, let me select lanthanum at first. Here, let me say something. Here, I have something like library and match program. All of these are suggestions from this program. I must select a structure near from my structure was working on it. You can take a good calculations by that take good results. Okay. To can do matching, I must select my contents. First one was lanthanum. Let me push on it. Here with this spot with a green cubic. Lanthanum. Second was manganese. Last one was calcium. Now, let me increase this arrow. The first 10 calculations are the best calculations data. By that, let me take a look. All of these contains from lanthanum, calcium, manganese, O3. Not all of these here, not O3. I'm working on some elements with O3, alkaline earth transition element with 3 atoms of oxygen to create a perovskite oxide. Because that, let me take a look to this option. Calcium 0.3, lanthanum 0.7, manganese O3. I think it's good. And here FOM asks to me how much this structure matching with my structure. Here, let's take a look to this result, 0.7532. It's a good matching result. Let's select this one. No change. Okay. This one is better. I have matching lines more than. Let me select it by push, by pass, double click on it. Bismillah. Now I have the structure, lanthanum, calcium, manganese, O3. It's a perovskite. It's more matching with my structure. Contains from lanthanum 45.800%, calcium 5.700%, 22.600% oxygen, and manganese 25.600%. Let me push on it and go to datasheet. By matching, I can learn some basic, but at the same thing, very important things. Let me go to datasheet and learn what they are. At first, the name, lanthanum, calcium, manganese, O3, it's a perovskite. The constructions of all of these. We go to this arrow to can know the crystal structure data. It's very important to me. The space group is PNMA. Crystal system is very important to me to know what is the single phase, ectohedral, tetragonal, orthorhombic. Here is orthorhombic. The cell parameters A, B, C, all these are written there. diffraction data, HKL, and I have a simple plot to the peaks. Here the 2 theta, here the temperature. Like I remember, temperature at y-axis, 2 theta at x-axis. Now the first mission is done. Let me come back to add again. Now I have impurities. Not all of these are matching, and that is normal because we have some mistakes in somehow. Because that now let's start to matching what is the impurities. Because I put two chemical liquid when I was prepared my perovskite oxide, new perovskite oxide. Chloric acid, I put it acetic acid and ethylene glycol. Let's start with acetic acid with Cl. And let's take a look what will happen. Bismillah. Oh, maybe I forget to matching the first cloud. Okay, I can solve it. I will just put restart here to clean what I selected. And after that, Bismillah, matching. Everything now is all right. Let me select Cl element. I have too much Cl lanthanum oxygen. That's mean chlorolanthanum. I have chlorolanthanum like impurity. Let's push the first one and see what will happen. Is approximately matched. Approximately my impurity is chlorolanthanum. Chlorolanthanum. Let's select this one, this one, this one. Some different here. Oh, this is the best. We have matching more than the other. Let me select this line. Now, Bismillah. Let me push double click on it. Let me select it and go to datasheet, chlorolanthanum, datasheet. Lanthanum oxygen chloride, chlorolanthanum. Let's take a look to crystal structure, space group P4 and M. Crystal structure is very important to me, tetragonal. It's suspected. Soil parameters A, B, and atom coordinates, X, Y, Z, diffraction data, HKL. This, the peaks plot. Everything is all right. Okay. Lanthanum 56.9, oxygen 16.8, manganese 15 point something, fluoride 7.600%. Okay, now let me matching it and go to try to analyze my data to try to make the line X to me the how much my data and the knowledge data in this matching program is matching. Bismillah, from this button, let me push on it and start for proving. Automatically or automatic reticle refinement, like I said at the PowerPoint presentation, reticle refinement will be our refinement. We can use it from foolproof, specifically from foolproof, from match program. But I will not work at automatic reticle refinement. We will try to run the reticle refinement from beginner selection. Bismillah, let me select, let me refine the scale factors of all phases from 1 to 5 refinement calculation. Bismillah. This line asks to me how much my data matching with the knowledge data in match program. Let's try to make this line be approximately something like line. Okay, these curves, these up points, these buttons, all of these sign to me, give message to us, our result is not perfect. Let's come back again to full proof. Now let me select shift or on to theta axis 0.1 to 5 refinement calculation, and let me select unit cell parameters. Run full proof again. Not very good. Let's go to full proof again. Automatically. Let's work on background. First, background parameters from 2 to 5 refinement calculation. And remaining background parameters from 4 to 5 calculation. Let me start from first background parameters and try. Doesn't change. Remaining background parameters from 4 to 5. Bismillah. Now it's damage. I will do that again. Okay, full proof, automatically no beginner. Let me start select factors, shift off to theta, unit cell parameters. Okay. Not very well. Let me work on atomic coordinates of all phases. Push. And back again. Let me try shift of to theta and unit cell parameters. Scale factors of all phases, just it's. Let me use it. of our shape parameters of all faces. Leave this. Ha! Now it's better. Approximately acceptable. And after that, we will work more to analyze it, to make this to work, to filter this line more by go to full proof directly and work on it. Maybe that I will explain that in the next lecture. That's it. That's all I have today. See you next lecture and have a good day.